So here are some formulas that are commonly used in valuation and calculating present value. The first one, perpetuity, is where you receive a fixed amount of cash flow for a period, forever. So for example, you receive the amount of cash flow C in year 1, in year 2, year 3, and all the way to the absolute forever, until after you die, after your 100th generation. And all these cash flows discounted back to the present value today, which is the C over R, where R is the discount rate or the interest rate. And then annuity is where you receive a fixed amount of cash flow, but not forever, for a fixed amount of years. So here, N is the number of years, and then I is the interest rate, and C is the amount of cash flow. So in an annuity, C has to be constant. And then I also has to be constant. So going back to that question, we can use the formula of annuity to calculate the present value of all the cash flows. And there is an Excel function that can give you the answer within 2 seconds at most. And I'm going to show you guys. Let me know when you're done.
This is my passport picture.
So remember how we got this answer by plugging in numbers by hand? But there's a function in Excel that enables you to directly calculate annuity value because it's such a it's so frequently used. So first you type in PV, which means present value, and then it will show you what input you need to have. So first is rate, and the rate is the discount rate, and here it will be 10%. Then number of payments, how many payments are there?
5.
Yeah, so you put in 5. And then PMT is payment, so it's asking for C, the amount of cash flow. So what would I put here? Yeah. And then FT, hold on. Richard, do you remember FT? What FT is? Oh, FV?
Future value.
Yeah.
I think it's a 1 or a 0.
What?
Wait. You can just press the formula button and it'll tell you what all that stuff is.
Like this one?
No, like the FX button. Like look directly up from where you are.
What do you
Hi.
do?
Above C.
So you see where that formula bar is on the top, which says PV? Nope, below. Nope, like the formula bar where you just typed in that formula.
Future value is...
Yeah, right. So to the left.
Left.
Left. There it is, that button. All right, so press FV and it tells you the future value.
That's what you want to have in the end.
Because we don't care about how much money would be left over.
Yeah, I think it will be just 0. Or just
You don't have to fill in those last two. You can
and
just do it.
type? Oh yeah, I have to talk about type here. So type you put in, it's asking whether the cash flow comes to you at the end of a period or at the beginning of a period. And in our calculation of present value, it's always at the end of period. So when we say we receive 100 in year 5, it's at the end of year 5. It's not in the beginning. So here year 1 is at the end of year 1. And you start at the beginning of year 1, which is time 0. So we will put in 0 here. Sorry. Yeah. And it's exactly the same. that's annuity. And growing perpetuity is just the situation where C is not constant. Instead, C is growing at a rate of G. So in that case, it will be 100 and then 100 times 1 plus G, and 100 times 1 plus G to the power of 2. And then the formula of such a series of cash flow will be C over R minus G. And then we will see situations where we use the three formulas later.
So the PV function, right? So it assumes it's a unit.
Yes.
Okay. So there's no.
Yeah, for perpetuity, I mean, you wouldn't even need to use the formula because it's so easy. And like, if you get familiar with finance more, you would just like memorize this by heart. And same as growing perpetuity. So the only thing you need to worry about is annuity. And one thing to pay attention to is that C is constant here, and also the payment starts at the end of the first year.
What difference is made? Payment made at the beginning?
So for example, if you also receive a payment at time 0, you can't, so for example, if you receive 200 here, you can't plug in the, or 100, you can't plug in the 100 in the formula, because the formula always assumes that the first cash flow starts from time 1. So if you did mistakenly plug this in, it will start discounting this, even though it shouldn't really be discounted as it's time 0 right now. So if you receive an 100 right now, it doesn't earn any interest, right? This is discounted only because there is 1 year passed in between. So it has the time to earn something.
So the timeline would say at the beginning of year 0, I invest this money.
Yeah.
And then I don't receive cash flow
Until
the end of year 1.
The end of year 1, yeah.
So there's like
1 year. Because time 0 is the beginning of year 1.
yeah.
And then this is the end of year 1.
Okay. Gotcha.
And the end of year 2. So that's one thing to pay attention to.
Everything's priced in advance.
So here's a practice question.
I can tell.
This is how,
Wait, sorry. So it doesn't really have to be at the end, the beginning or the end, right? So as long as I
it's 1
start,
period away, yeah.
yeah, as long as I start receiving cash flow a year from,
Or like 1 period away. It could be a month.
yeah,
or
1 period
2
away.
months.
Okay.
Yeah. And this is like an example where the theory of time value of money is used in practice. So if you're considering if you should invest 800 in a project, if you do, you receive cash flows of 100, 200, 300, 400 for the next 4 years. And the discount rate, the interest rate is 8%.
He's making size.
Should you take this project?
I thought you were saying.
So are we comparing, what would that be, $1,000, which is what you get if you invest?
Oh, it's 800.
Oh, yeah, sure, but so you say if you do receive cash flows of $1,000, so
Yeah.
are you comparing that to what you would make if you were to invest $800 at 8%?
Yes.
Right.
Yeah, you can do that. Yeah. Yeah, that's right. So how would you approach this question?
So you discount the cash flow